All right, welcome back, guys, to Foundations of Programming Day 8. Today, we're going to begin the Python crash course. We're going to close up the door for the front end, working with HTML, CSS, and JavaScript. And now we're going to talk a little bit more about Python, how to work with Python, which will then transition into object-oriented programming. As I've said multiple times before in the course, where it's like the main meat and potatoes of this course, and where you'll get the most of your um, bang for your buck for your time here. Um, Once again, reiterating, this Python crash course is under the impression that you have a somewhat of an understanding of JavaScript. Python is a high level language, um, which once again is it's a language is very familiar with English. Most of these languages are very interchangeably. The concepts stay very similar. Um, the things that change are some syntax declarations and how we do certain things. But the concepts of like variables stay the same. Data structures, data algorithms, stuff like for loops, while loops, functions. All these are pretty much all the same, and across the board with the different types of high level languages. It's just some syntax differences, right? If you were a native English speaker, right, in this scenario, you started with English or you start with JavaScript, and you want to you learn Spanish, right? If any of you guys took Spanish classes in high school or middle school, you would know that there's certain words that are fairly similar on how they are written in English, but the way they're pronounced, or it might be like a slight difference. Um, like for example, car, right? In English, in Spanish is carro, right? It's spelled the same as CAR, but it has an extra R and an O at the end. But you can kind of identify that what that word is just kind of by looking at it, right? They're very similar in that respect. Um, Now, in that same aspect, because this lesson is under the impression that you guys have some kind of understanding of JavaScript, it's not going to be a full immersive course in Python. We will talk about resources you can use for Python if you like. You'll get a much more in-depth course in Python. But to be completely frank with you, if you already understand one language, a lot of these things might seem a little too easy for you guys to start off, right? If you guys took your own personal course starting, in your journey, if you looked at some kind of like Code Academy or some kind of coding application, or if you went to Udemy and you found some kind of programming course, they all start very simple. They start with like variables, data types, how to declare the variables. Um, so, which is one of the reasons why we don't go too in depth in Python, because it's very interchangeably, and it would just feel a little redundant talking about some of these more simpler concepts, right? So we'll talk about the syntax, how it's done in Python, and then compare it to JavaScript, and hopefully that gives you a good understanding. And you'll get most of your learning done, honestly, by just kind of doing it. Um, Once again, I've been doing this for 2 years, and even with coding for 2 years, every now and then I still forget some syntax here when I'm changing between different languages. It just happens, right? You get them confused, or you kind of mix them up. You're coding JavaScript, but you start coding some Python code, and it's not the same. But then you kind of realize your error halfway through. And that's okay. That's normal, especially if you start adding a significant amount of different languages into your tool belt. It's just something that gets better with time and practice. So without further ado, let's go ahead and start our lesson. All right, so what is computer science? All right, I'm sure some of you guys have probably been in college before. If you look into college, or you've done some research into programming, if you thought about taking some kind of degree plan to become a programmer, usually the typical and most common route is receiving some kind of degree in computer science, right? But the stuff with computer science is not just programming; it's an addition of different things, right? Um, it's data structures, algorithms. It goes more into also the hardware of your computers. It adds a lot of extra fluff. Not to say that's not important. It's always very important to know a little bit of everything and understand everything you're doing. But coding boot camps, we tend to focus on what you're actually going to be doing in the real world, right? It's kind of one of those where you took a chemistry class, but you're trying to be some kind of like accountant, right? Or you want to do finance or something, right? You want to start business, but you need your general ed, so you need to learn chemistry, and you're like, why am I taking this dumb class? I don't need this for what I'm trying to do. It adds a lot of extra fluff that sometimes you won't actually really use or ever even touch once you actually get into the real world. Um, and there's a difference between computer science and being a software developer, right? Or software engineering, because these words are kind of used interchangeably a lot throughout in the industry. But the biggest difference is, if you try to pursue some kind of computer science degree, you're going to see a lot of math and a lot of different theories and working with how stuff actually works, and it get very complex. Um, you talk a lot about pattern and pattern recognition and stuff like that. It's a lot of numbers. Whereas for software engineering or software development, we're not worried about all this data stuff or data analytics or data science. The biggest thing that we focus on is creating the application and making it work and figuring out ways to make it better, right? You don't need to know physics to be a software developer, right? Now, if you went to a different route, you can see here we have a bunch of subdisciplines. If one of the routes you went into was, let's say, game development, and in your game development, you're creating a character that was supposed to be, maybe shooting an arrow towards the enemy. Uh, then that's where it might come in handy to know like physics, right? How to manipulate or replicate gravity into your game, and working with trajectory and more complex math. And, for some of you guys that might not be complex, but for me, I'm not very good with math. So, but computer science focuses a lot of more of these different stuff. Whereas for us, we don't worry too much about that. Computer science translates the science of information in many languages. Right, so you focus more on the nitty gritty stuff, whereas here we're just going to focus on what's really important and what's going to make you earn the big bucks, right? We learn programming language so we can express our algorithms. So before we had asked like, what is a program? And a program is essentially just an instructions that you write for your application, right? So the computer can read it, right? And the programming languages allows to express ourselves in its language, so it understands what we're trying to do. This week we're going to be learning about Python, and this is going to go on until next week on Friday, where we'll be heavily Python focused. We'll still be working on Python for the remainder of this course, but we're not going to be focused too much on Python fundamentals or principles. We're going to be using Python to just solve data structures and data algorithms, right? But for the remainder of this course, we're going to be doing nothing but Python. So hopefully when you do get into the course, you already have some kind of a solid understanding of how Python works. You've had some time practicing it, and the first time you're seeing it is not actually going to be the actual immersive program itself. What is an algorithm? Right? Who can take a quick guess of what is an algorithm? It's on the slides, right? But essentially, it's a pattern, right? It's a pattern to either manipulate or transform information. And the code snippet you have here is you have random numbers. You have 2, 6, 10, 14, and 18. And then you have another line here of 1, 4, 3, 6, 5, 8, and 7. I'm not gonna lie to you. I don't know what this image is doing here. But I'm assuming that what the picture trying to convey is, you can use data algorithms or essentially a pattern to be able to achieve a goal, right? And for example, let's say if you had a list of different integers, right? A very simple algorithm, and you wanted to to move the items in the list so it formats the list in a ascending order, right? You would essentially come up with some kind of pattern that would take an item in your list and then put it in its respective place, uh, where it will represent the ascending order of these numbers, right? Um, and we use patterns to solve our different complex problems that we were going to encounter. We call it a pattern sometimes because it must work for all cases of the problem and not just one specific case. And you guys probably ever encountered this when, if you've done any leak code or if you've done some code wars. You'll think you have a solution, and then you run your test and you'll pass like 2 out of 10. And then like the other ones that you didn't pass, you'll have some exceptions. Like, what if the input that was given to you was 0, or if it was none, or if it was like this humongous number? It would exceed the runtime, which we'll talk more about later on. Um, a very good pattern should be able to solve all cases, not just one. All right. An algorithm is a step-by-step set of instructions for accomplishing some task. Do I have any questions so far on what we've been talking about? This slide is better represented, honestly, within the data structures and algorithms section of our course. So if you feel it's a little out of context, that's okay. What is computer programming? An algorithm that is expressed in some specific computer language. We'll be writing our algorithms or instructions in Python this week, right? A computer program, once again, we've asked this question before in the first part of the week. It's just a set of instructions. Now, let's go ahead and kind of open up our VS Code. You are more than welcome to walk through the slides as we go through the lesson. As I progress through the lesson, I'm essentially just going through slide and talking about every single key point that's being brought up. So if you're wondering, the pacing of the class, you can always just have the slides and use them as reference. But I'm going to have VS Code open up for the remainder of the lesson. So I'm going to code out in real time. And I highly recommend that you also have a Python file opened up for you guys so you can try it out as we go. Everything that we do should be pretty simple. There shouldn't be no complex code where it's like, 5 or 10, 15 lines at a time, and then you fall behind. So it'll be simple things like declaring a variable, starting a for loop, using specific methods, and just running our code, right? Just practice with that. If at any point anybody has any questions, please stop me. I do not have. Actually, let me just move the Zoom call to the left side. I do have the chat open, but just stop me in my tracks if you have something to ask or you want me to elaborate a little bit more on any of the methods that are going to be covered throughout today's class. All right. So, running Python locally. You might not have noticed this, but you actually already installed Python. It should have been done throughout the install fest. So you don't have to do anything today. It should already be in your virtual machine if you've gone through the entirety of the install fest. Is everyone looking at my VS Code right now? Okay, good. Right. But normally, when we run a Python file, you want to call Python 3 and then the name of the file that you're trying to run. Now, throughout the install fest, there was a small section where we made you set aliases for certain commands. I think it was honestly just Python, if I'm being straightforward with you guys. But that alias that you guys set should allow you to just run Python files with just the word Python. It sounds like, oh wow, like thanks, Roger, like that was really helpful. I know it's just like a split second to add that 3, but in the event you forget the 3, like it'll still run, and you can still run it even if you just type in Python 3. But no need for the 3 because you do have that alias set in your directories. You probably just don't remember it because you're fairly new and you didn't know what you're doing with this office, and that's okay. But to run a Python file, if you want to call Python and then the name of the file, right? In this situation, I have a python demo.py. So I would do it as such, and then it will run my file, right? If you're familiar with JavaScript, then obviously you know that we will use node and then the name of the file. But because this is Python, we're using the word Python to declare to our terminal that we are trying to run a Python file. Right? Do you have any questions on how we run a Python file? I mentioned to you guys before, you want to avoid pressing this run method here because you want to get used to just working in your terminal. This is always good practice. Also, avoid right-clicking and putting run Python. Use your terminal for all commands. Now, the first thing we're going to cover is how we actually do the version of console.log, but in Python. And once again, because Python is a high level language, it shows a huge similarity to English. I started with Python, so I really enjoy Python. I'm a little biased, but I think it's super simple. That in Python, if I wanted to print something in my console, instead of saying console.log, which technically does make sense, right? You're calling the console and you're trying to log some kind of record, right? Console.log and the string, you just say the word print, right? We're going to use the word print. And just like console.log, we're going to open it up with some parentheses and add whatever you're trying to print out. Hello, this is my first Python file, right? And it seems like I'm getting error here. I wonder why I'm getting error. Let's make sure I'm good. Python-demo.py. Oh, do I have an indent? Oh, my bad. That's why I was like, why is it giving me the squigglets? There we go. We'll clear this out. So the first command we're gonna talk about is gonna be the print method, right? So print, just like console.log, is gonna allow you to print out a string, or you can print out variables. You can chain them together as well, right? So you can say, hello, this is my first Python file, comma, this is my other print statement, right? So you can add multiple things here. It's the exact same thing as console.log. Nothing changes except the way that you're calling this command. All right. User input. So we know how to give an output, but how can we receive input from our user, right? How can we receive input? Well, Python has a method for that. I'm not too familiar with JavaScript does. I think it does. I haven't really used a JavaScript. But we could do something like this. We're going to create a variable. And unlike JavaScript, that you have to specifically call or use a method to declare to your code that you're making a variable, you don't have to do that in Python. You don't have to say something like let name equals to whatever you want to name, do that. You don't have to do that. Python is smart enough to understand that you are trying to create a variable, and you can just call the variable itself right off the bat without you using the word let or const or the old version, which is var. You just call the name of the variable right off the bat, right? And then after you name your variable, you give it what you want to name it, which will be Roger. All right, my name is Roger. Right. In this matter, what we are going to do is I'm gonna go ahead and create a new variable. I'm gonna call this user underscore input. Now notice how I'm naming this variable, right? What you guys are probably familiar with is doing a variable like this, where you say user capital I for inputs, right? When working with JavaScript, and this type of naming convention is what we call camel case, right? Now, why do we do this? Well, it's just kind of a standard that people use to kind of be able to identify what type of language you're kind of using. But in Python, we don't use camel case. we use what we call snake case, right? Where at the start of every new word, we add an underscore to separate the words, right? So instead of user input with a capital I, you're gonna say user underscore input, right? And this is what we call snake case. We'll go ahead and zoom in a little bit so we can see it a little bit better. Now, after declaring my variable, it's not complete. I have to finish the declaration. But what I'm going to do is I'm going to save something that comes out from my input method. And I mentioned that we can receive input, but how do we do that? Well, to prompt the user for input, we use the command input, and we do open and close parentheses. Right, and let's see what that does just by itself. Let's go ahead and say print user underscore inputs. Let's see what happens after I run this method here and assign the response of this into this variable called user input, and then I print it out. Let's run this Python file. When I run it, you're gonna see here that in my terminal, it opened up almost like an input prompt, right? It's asking me for inputs, and if I start typing in my keyboard, you'll see here that I'm able to give input to this section, and I'm gonna say, "Hey guys, this is my input example," and when I press enter, it's gonna save this information that I gave in my terminal into the user input variable. And then on line 4, it's going to print it out. As we see here, this is me typing it in, and this is it printing out. Now, what happened? Well, when I ran this Python file, it got to line 2. It checked this variable that I'm calling, called user input, and it's seeing, all right, well, what are you assigning to this variable? Oh, I see. In this variable, you are calling a function so you can save it into this variable. Well, what input is doing, it's doing exactly what we saw here earlier, where it's going to prompt you for information in your terminal. And then it's going to save that to whatever variable you assigned it to. What you can also do is you can add a message within this input tag right here within the parentheses, and you can say something like, "Hey, what is your name?" And when I run this Python file, you're gonna see here that it's not just prompting me for input, but it's also giving me the message. And it's asking me, "Hey, what is your name?" Well, I can say Roger, and then we see here that it prints out the word Roger afterwards, because that's what I saved into this user input variable, right? Well, we can make this a little bit more dynamic. What if instead of just returning to me the text Roger, what if I do some string concatenation? And very similar to JavaScript, we can do the plus to concatenate different strings. We can say something like "nice to meet you," comma space, plus user inputs. And now when I run this and I pass in my name as input, I can see here that it's going to greet me back, right? It's going to print out "nice to meet you," as well as what was saved into the user input variable. Right, so we're able to prompt the user for input and then use that input later on in our code by saving it into a variable. An example would be the one on the slide, which is creating a variable called favorite animal. And we're going to prompt the user for some input, and we're going to ask them, "What is your favorite animal?" And then I want to print out your favorite animal is space. And I'm going to concatenate the favorite animal variable. And when I run this, it's going to ask me, "What is your name?" Oops, my bad. Let's say Roger. What is your favorite animal? I'm going to say a rabbit. Your favorite animal is rabbit. Maybe I could have formatted that text a little bit better. But do you guys get the idea of working with the input method, declaring the variable, and printing it out, as well as concatenating strings? All right. Very simple. Very similar to JavaScript, but a little bit more user-friendly syntax, right? Nothing too crazy. You don't have to use extra jargon to try to receive the same output, right? All right. Let's move on to the next part. Let me go ahead and comment this out. The next thing we're talking about is going to be floats and integers, right? Floats and integers. I'm going to create a variable here. I'm going to call it decimal. And what I'm going to do is I'm going to pass in the number 5. And then I'm going to print out what this is. Now, just like JavaScript, how you can do the command of type of, you could do something very similar to that in Python. But instead of type of, all you have to do is type. All right, so we can wrap this response inside of type. Let me pass in the decimal and see how this works. What is it? When I run it, it's going to tell me it's a class integer, right? So by default, if you just add a number, it's going to automatically turn into an integer. Just like JavaScript, if you add the quotation marks, it's going to make it into a string. Now, if you want to convert this data type into a different format, what you're going to do is you're going to do what we call typecasting, which I'm sure you guys have heard this this term before. But that's essentially you're converting one data type to another. And what I'm going to do here is I'm going to convert this number or integer of 5 into a decimal. And to do that, we're going to use what we call a wrapper, right? I'm going to wrap this around the data type that I'm trying to convert it to. And to convert it into a decimal, I think JavaScript is the same thing. It's called a float, right? It's called a float. So if I want to make this into a decimal, I would wrap it around the command of float. It's going to take whatever's inside of it and it's going to convert it into a decimal. So let me go ahead and print out the type of decimal, and then I want to print out decimal as well to see what it looks like. And we now see that when I print out the type of decimal, it now tells me it's of class float. And when I print it out, it's now converted into a decimal. Okay. Well, what if I want to convert it back to an integer, right? The command for on JavaScript is something that can be a little confusing. I think it's like parse int or something weird like that, right? Or to integer, or I don't remember what it is off the top of my head. But if you want to convert this decimal into an integer, what you would do is you're going to do typecasting again and use a wrapper. But this time, the wrapper you're going to utilize is going to be the int wrapper, right? So we'll say decimal to integer is equal to int, open and close parentheses. This is my wrapper. And in this wrapper, I'm going to pass in the decimal. And then once again, I'm going to print out the type of it. And then I'll print out decimal again to see how it works. So what it should show us is when it's first a decimal, print it out in the decimal format. We then convert it, and then we're going to print out what happened after we use the int wrapper. And as you probably guessed, oh, what the heck? What happened? I think
decimal to integer name.
Decimal to integer.
Yeah, yeah. On 1415, it's supposed to call it decimal to integer.
Oh, my bad. You're correct. Decimal to integer. Thank you. Yeah, I also overlook things, as you guys see. I am human. Let's run it again. Oh my god, Atlas. There we go. Clear. Run it again. There we go. Well, the first one has it in the float, and then we were able to convert it into an integer. Well, what happens if this decimal is 5.2. Well, although decimal was 5.2, right? It showed us it was a float, right? It prints out the 5.2, and then we use the int wrapper and print it out again, and now return to us 5 once again, right? So as you can see, it still converts it, but it truncates and rounds it down. Now, what do we do? 5.5 or 5.9? It truncates all the way to the bottom. Now, there is a way that you're able to either round up or round down, which we'll cover later on. But this is how you typecast from float to integer, or from integer to float. Now, what if I wanted to convert into a string? Well, same concept. Decimal is equal to 5.0. If I said decimal underscore to string is equal to, and I want to convert this into a string, I'm going to use another wrapper, but this is going to be the string wrapper. And I'm going to pass in the decimal in here. And then I can print out the type of decimal to string and also print out decimal to string. And we can see here that it is a class string. It looks the same, right? It didn't convert it. It didn't truncate. It didn't remove the decimal. It took this decimal format and just made it into a string. So technically, this is two numbers, the 5 and the 0, and there's a dot in here, right? It takes the dot as a character, right? So we're able to convert from different types using these wrappers, right? It's a lot more user-friendly compared to JavaScript, where the syntax might be a little confusing sometimes, right? Very straightforward. Do I have any questions on the conversion of our data types? All right. Now, we talked a little bit about string concatenation, but let's see it at work very specifically. Now, there's two ways to concatenate strings, and you probably are familiar with that with JavaScript as well. One was using the plus method to grab two strings and join them together. In JavaScript, you might recall that you use backticks, curly braces, and a $sign to specify where the variable should be, concatenating within the string. In JavaScript, I'm sorry, in Python, it's a little bit different. Well, first and foremost, let's go ahead and let's create two strings. So we'll say string 1 is equal to hello, my name is space. And then we're going to say string 2 is equal to whatever your name is. And then I'm going to create a variable called concat string is equal to string 1 plus string 2. And let's print out concat string. And as you may already guess, as we saw earlier, it's going to combine our two strings, right? Now, what if we wanted to use some kind of value within the string? Well, the way we do that is we use what we call an F prefix, right? So let's go ahead and say age is equal to, I'm not going to give you my real age, I'm going to say 50. But I want to concatenate 50 within this string, concat string. So we can say concat string 2 is equal to, and then to start some kind of formatted string, we're going to use the F to let our Python file know that we want to essentially format some kind of string using variables, right? So instead of the backticks, we use the F, right? We use the F to declare that this string is going to be formatted, right? Which is what the F stands for. And then we open up our quotation marks, whether single or double, right? And I'm going to say concat string. And I want you to notice that whenever you concatenate a string using the F prefix, you don't have to add a $sign, right? This F already lets your code know that, hey, there is going to be variables in here within curly braces, right? So we don't need to add that the $sign before the curly braces. All it requires is that F to start. And then afterwards, whenever you use a variable, all you have to use is the curly braces. So we'll say concat string, and we'll say, and my age is, and once again, I'm going to add a different variable, which is going to be the variable age. And when I print out concat string 2, we'll see here, hello, my name is Roger, and my age is 50. All right, so two different ways of concatenating string. We have the plus method that will join together, or we can use the F prefix to create a string using quotes and then add variables within the string as well. Do I have any questions on concatenated strings on either method? Now, what I recommend as we continue with this lesson, if you're coding along or if you're taking notes, I recommend starting Anki. Start an Anki deck, right? If you have the Anki application downloaded, this is a perfect time of when you can do this, right? As we're going to the lesson, maybe you can just start making your flashcards as we go to ensure that by the time we're done with the lesson, you have a complete deck that you can just utilize to go through and practice the syntax. Especially if this is the first time that you ever seen or been used in Python, your biggest hurdle and the biggest issue you're going to be having when you start coding this week is you're going to be forgetting the syntax of how to do things. So definitely, spend maybe 10, 15 minutes every day if you can. Open up your Anki deck and then scroll through and try to remember how the syntax is written so you can get better at it. We talked about casting from string to integer. But what if we start as a string? Age is equal to 50, right? Then I'm going to say age is equal to int of age, and let's print out the type of age. And it works the same. Now, if I add something like 50s, you're going to get an error, right? Invalid literal for int with base 10. What this is specifying to you is that it is not able to convert it from one type to another. So if you ever get a value error, that's what it's referring to. The value that you're saving to some kind of variable, right, does not work. This here does not work because there's an S. So it doesn't know how to convert this into integer because there is a letter in here. But if it's specific numbers, then you should have no problem. So you can go from string to integer or integer to string and vice versa. Is anyone here familiar with stuff like or languages like Java? No? Okay, good. That saves me some time. In Java, you have to declare specifically what you're trying to create. So it'll be something like string name is equal to Roger. Right? You would have to specifically state what type of data you're creating. And one of the issues is when you have something like integer age is equal to 50, and you try to convert this to a different type of data structure or data type, because we have stuff like big int, it becomes an issue when you try to upscale or downscale a specific number. But that saves me some time. Booleans. So Booleans are fairly similar to JavaScript. The only difference is capitalization, right? M I awake is equal to declare a Boolean, you guys are probably used to something like true, all lowercase, but in Python, they care about capitalization. So to ensure that something is not just a string, but is actually a Boolean, you have to use capitalization, right? The way that Python interprets a Boolean is using the capitalization of the true and of false, right? Pretty straightforward. No big change there. Just the punctuation or the capitalization of our true and false. So only difference here for booleans is the true and the f and false are capitalized. And just like we were able to check the type of integers or strings, you can do the same thing here. We can say print type of am I awake? And we run this, you'll see that we get class bool for boolean, right? So you're also able to check the type of your data on a boolean. Good to move forward. As you can see, this is why it's called a Python crash course, right? It's very quick. For the most part, a lot of things you've already done before, you just didn't realize it. It's just some small syntax differences.
I got one quick question. You know
Yes.
how in like JavaScript you end every line or every specific line of code with like a semicolon? Do you have to do that in Python as well?
Technically, JavaScript won't force you to end it in a semicolon. It's good practice, right? The ones that do force you to end it in a semicolon are stuff like Java. Java is very specific. When you try to compile your code, you'll get an error if you don't add the semicolon. But in
Hmm.
Python, no, you do not.
Okay.
You're not forced to. It's not even an option. I think it'll probably even give you an error. Let me double check. No, it doesn't even recognize it. You can see it's whited out, right? So no, no semicolon.
Okay. Thanks.
No problem. All right, basic arithmetic is next. And just like JavaScript, it's fairly similar as well. If I wanted to add something, my sum, I can say 3 plus 4, and I can print out my sum. And the addition will work the same. For subtraction, we can say difference is equal to 3 minus 4. And just like JavaScript, let me go print out difference. That works the same, -1. For multiplication, same concept. Product is equal to 3 times 4. We use the asterisk to multiply. And we get 12. For division, we have quotient is equal to 3 divided by 4. And we can print out quotient. I'm not even going to pretend like I know what quotient means. But we get 0.75. We can also do absolutes. It's a nice nice thing. I think JavaScript has it too. But let's say we have something like let's see. Overdrafted is equal to -5. If you want to get the absolute result of how much you owe, or the absolute of a number, we can say something like absolute num is equal to, you'll get the word overdrafted, which holds the -5, and you're gonna wrap it around parentheses with ABS as a prefix. And what this is gonna do is going to take that negative number and give you the positive version of it. So if you ever have to work with negative numbers, but you want to make sure you use the positive version of it, you can grab the absolute version of that number. In Python, something to take into account, as you saw here, when we divided 3 divided by 4, we got a 0.75. But what if we did something like 12 divided by 3? 3 give us 4. But notice that it's also in a float, right? So even though 3 divides into 12 equally, it's still going to give you a float. So you want to keep that in mind. Right? If you wanted its full number, you would have to do something like typecasting to print out the integer version of it to get rid of that float. Any questions on that? Division will give you a float, so keep that in mind. I think JavaScript is different. It will give you the whole number. In Python, it will give you a float. Floor division. If I have 20 divided by 3, let's say result is equal to 20 divided by 3. What does that give me? It's going to give me some weird number, right? 6.666666667, right? Well, we can do floor division, which is just a fancy word of dividing and rounding down to the nearest whole number. And to do that, we use 2 forward slashes. This lets your code know that you're not only trying to divide, but you want to round down to get the whole number. And it prints out, notice that it goes to 6. Now, the keyword here is floor, right? It's not rounding up. It's going to round down, right? So it's not getting to the nearest whole number. It's going to round down to the nearest number, right? Round down to the nearest number. All right, math.floor. I want to say there's a to round up. Yeah, math.ceil, C-E-I-L, right? So if I said math.ceil, it'll work differently, but that is not native to just Python, right? If you wanted to round up, you would have to do something very specific and using what we call a module, which I'm sure you probably heard before. If I wanted to round up, it's not one of the default things that come with Python. You have to import it, right? We have to import math. And what we can do is say math.ceil and wrap our division around the ceil method. And okay, that didn't work. Cool. Oh, my bad. Let's go ahead and remove this extra forward slash. There we go. And now we get a 7. Right? So just like you're able to round down, you can round up. The only difference is if you want to round up, it's not the default version of the round method. You have to import a method from math. Right? And for those of you that are not familiar with modules, technically it is a part of Python, right? But you don't have straight access to it like everything else. You have to import it. When you installed Python to your computer, it came with some additional functionality that you didn't necessarily see, right? It came with some extra files, which are essentially what we call the modules. And these extra files add some additional functionality to your code that you have accessibility to it, right? But if you want to use something very specific, you have to import it from the Python download that you installed, right? And a module is exactly what that is. It's just a file, right? It's some file that you're importing into your code so you can utilize the code in that file, right? I think if I right click right here, math, and I go to definition, it's gonna open up the file of where this is actually created, right? It's a lot of code here, right? But there's a lot of functions that you downloaded when you grab Python and install it into your computer, right? You have access to these, but to get access to them, you have to import this file into the file you're trying to use it, right? So this is what we call a module. It's just a fancy word for a file somewhere, right? When you import a file into your code, you can import the entire file, or you can import a specific function. And that's what these really are. These are all functions, right? We can probably find the seal function in here, right here, right? The find seal. This is where the function is created. It was made by somebody smarter than me that works with the developers of Python, and they added it to the latest Python version. Right, it's been out for a while, but just like you can update applications, update games, just like your iPhone update, like software updates, Python itself is something that someone has worked on, that they created themselves. They coded out. They've, I don't know how it works, if I'm being honest with you, because I've never created my own language. But the person that created the Python language, they're still running it, right? They're constantly running updates to better improve Python, right? And that's for every language. JavaScript has the same thing. And a prime example is like when we declared variables in the past, we wouldn't use the declaration of let. It used to be var, right? Var used to be the standard of how you declare a variable that should be able to change, right? Var standing for variable. But somewhere online, someone thought it'd be better if they changed to let. I believe var will still work, but it's no longer like the way to do things, right? So things get deprecated with time, and no longer become current, right? But this is done through updates. So whoever created this file has added it to the Python language, and when you install Python, you now have accessibility to it, but you have to import it to have direct use of it. Now, by saying import math, I was able to import the entire file, and that's something to take into account. When you import the entire file, it's going to import all this information. Now, what if this is 1,000 lines of code, right? That's a lot of space that you're taking. So when working with modules, if there's only one specific thing that you want to use, you can say import math.seal. And I guess it's not working. Math. No, why isn't it working? Maybe because it's one of those that comes with Python. All right, we'll talk more about this later, but there's a way to import specifically just the function that you want to work with. For some reason, I'm getting an error here. Maybe math doesn't work that way, but we'll talk more about this. All right, but once again, if you want to use a ceiling method, you have to import math to round up. All right, we're going to take a quick 10-minute break here. We'll come back at 6:40. I'll see you guys in a bit. All right, so before we went on break, I was trying to import math, and I had a mistake here. So when you want to import from something in Python, you have to either you import the whole file in the same manner we did, import math, or if you want to specify something very specific, you say from math, import seal, right? And now instead of using the math prefix, all you need to use is the seal method, because now you have access to it. But just the seal method, nothing else, right? Because we specify here that I do not want to import the entire file. I only want to import this specific function here called seal for sealing, and then I can use it. But because before I wasn't doing that, I was just importing the entire file. I have to call the file that I imported, and then the method from that file to specify, hey, this is what I'm trying to use. Does that make sense? All right. Let's go ahead and move on. Sorry, excuse me. All right, so the next thing we're talking about is going to be exponents in concatenating lists, right? So we saw product was 3 times 2, and this would multiply the result and give me 6, right? Now, what if I want to do 3 to the power 2? Well, that's going to be used with the 2 asterisks to let it know that, hey, you want to do 3 to the power 2, right? So an exponent of 2, and that would give you 9. All right, so exponents using 2 asterisks. Pretty simple. Now, we also saw that we were able to concatenate strings using the plus sign, right? And that worked. But what you can also do is you can use the plus sign to concatenate lists. All right, so if I have list 1 is equal to 1, 2, 3, and I have list 2 is equals to 4, 5, 6, I can print out list 1 plus list 2, and it'll concatenate the list for me. Which kind of opens up the next door about declaring list. Same thing as JavaScript, you're able to do that with the square brackets. Right? So we can concatenate strings using the plus method, but we can also do that on lists.
Are they called specifically lists and not arrays in Python?
Yes, right. The terminology is different in Python. And you're going to see that for a couple of the things. But in JavaScript, they're called arrays, and Python, they're called lists. Now, technically, there's the same thing in both JavaScript and Python, but fundamentally, arrays are actually different, right? Arrays are typically pre-formatted types of data of the same type, right? Of the same type. So you'll see this in JavaScript. You can't do something like 1, string 2, and then 3.0. This would not be able to work in stuff like Java, right? Because they're very strict with their arrays, right? You will not be able to use the different data types. I'm not quite sure why JavaScript calls them arrays, even though they're still technically lists anyways. But yes, the naming convention is different, but they're essentially used the same way, and they're the same thing, but just called differently. For the remainder of the time in Python, I'm just going to use nothing but the word list. So just be aware of that. Now, there's a couple things that you might encounter when working with your Python code. And that's going to be the common Python error messages, right? And these are going to be the first ones that you're going to be seeing as you start off. And the first one is going to be EOF, right? Which stands for end of file. And if you ever receive this message, the chances of you getting them is due to the fact that you probably forgot a parenthesis somewhere, right? There's some kind of issue with your file and you forgot a parenthesis when you should have had a parenthesis and it's never closed up. But the more common ones are these three right here. A name error, right? You called something before assigning it, right? And to show that, if I try to print out list 3, right? Notice that it's already giving me an issue, right? Because at no point did I define it, right? I'm gonna get a name error. Name list 3 is not defined. Did you mean list 1? So it tries to kind of correct you and get you to the right spot. but I'm trying to call a variable that at no point did I declare. So name error is going to be due to the fact of you trying to use a variable that does not exist, or in a different word, is not defined. The other one is going to be syntax error, right? Check the spelling in your file. A syntax error might be something like get rid of this issue first. Okay, how can I do this? How can I show you syntax error? What do I say? There we go. This is a syntax error, right? So I forgot a quotation mark in here, right? So the spelling or the syntax of how I tried to create a string was incorrect. So I got the error here, unterminated string literal. It doesn't know that this is a string, doesn't know what the heck this is, because for one, if it was a number, it shouldn't have a quotation mark next to it. And if it was a string, it should have two quotation marks to the left and to the right, right? So this returns to you a syntax error. There's another common one that you're going to encounter. And last but not least, it's going to be the type error, right? You're trying to perform some action on the wrong data type, right? An example would be printing out 5 plus 5, right? I get a type error, right? Where it's unsupported operand type for the plus, right? So I can't, it does not support the ability for me to add an integer with a string. Now, I believe in JavaScript, this actually might work, but in Python, it won't. All right, so it's good to keep that in mind. I believe in JavaScript, it's smart enough to tell if this is if this could be an integer or not. Python, it's just gonna fail right off the bat.
Could you, within that parentheses and after the addition, could you put like int and then put that 5 into commas? Would that work?
Yes, that would, right? Because here you're specifying, hey, I want to take this string, convert it into an integer, and then add it to 5. So yes, this will work. Do you have any questions on the common Python error messages? And the reason we talk about these is because understanding error messages is probably the number one issue you're going to encounter when trying to debug your code, right? Especially once you start getting into the cohort and you go through the assessment. All your assessments, the way they are graded is when you clone your assessment to your computer, right? Because it's going to be some kind of repo. It's going to come with a test file, right? And we'll talk about tests and how to run them. But you're going to run this test file, and it's going to run all these tests against your code. And when it fails, it's going to give you like 10 to 15 different red lines of error messages, right? And it can become a little overwhelming, especially if you're not familiar with the error messages, right? Because then you won't know where to start. All you're going to be seeing is nothing but red, and you're going to be wondering, why is this failing? And if you don't know how to read the error message, you won't be able to debug your code. So getting familiar with the error messages and understanding what they're telling you is going to be the solution to that problem. And we'll get some practice working with tests, creating tests to test our code, and seeing the errors that we're getting to understand where our code is going wrong. And these Python error messages are just the start. All right. Now, that's the first part of Python course. That's like 1/4 of it. We're going to jump into a exercise real quick, and that's going to be the coins.py. So in lesson 7, I want you to open up coins.py. the README. My apologies, not the coins.py. The coins.py is going to be empty. You're going to want to open up the README. Your code is going to go in here in coins.py. But in the README, you're going to see the instructions. You're going to write a program that's going to ask the user for an integer, right? Or essentially a number of cents of integer type from 0 to 99. And it's going to output how many of each type of coin will represent the amount with the fewest total number of coins. And we'll see an example to really understand what this is saying. All right, when you run your program, it should match the following format. You should get something like this on your terminal, where it's going to say, please enter an amount in cents less than $1. So you might put something like 87, right? 87 cents. And then this is what the output should be, right? You should be able to say your change will be, and it's going to break the number that you gave it into the input into what it would be in change. And then we see for Q, which is quarters, is going to be 3, which will make it to 75, right? After that, the next biggest one is going to be dimes, which is 1, right? Because we can't have more than 3 quarters, because if we go to 4 quarters, that would equal $1, and it would exceed our amount. So after we identify how many quarters fit into 87, we then go to dimes, which is 1, right? So it goes from 75 to 85, which still we need to take into account 2 more. We can't go to nickels because nickels is 5. We will exceed the amount. We're looking for 2. So then it goes down to pennies, which will give us 2, right? Here you have a little hint that you might find the operator useful. I don't think we actually covered that. Give me a second. That's weird. We should have covered it. Okay. Well, I'll cover it so you guys don't have to guess. Before we actually break up into the assignment, we can use the modulus operator. And who can take a quick guess on what this does?
Just tells you how many is left over after it can't do that number again.
Correct, right? If I said result is equal to 75 modulus 25, what is this going to return to me?
Zero.
It's going to return 0, right? Because what this is going to do is going to divide the 75 by 25. And what it's going to return is how much is remainder from this division. When I run this, I get 0. Now, if I add 70, let's go with 80. If I do 80 modulus 25, it's going to return 5 to me, right? Because 80 divided by 25, 25 was able to fit into this 3 times, which was 75, but there was 5 left over, right? It couldn't fit 25 into the remainder of the 5 left over in this 80, right? So modulus will return to you the remainder of a division, right? It won't return to you how many times it divided it. It's going to return to you the remainder of the division. Make sense, Chase? Sorry, not Chase, Jason. All right. I'm assuming Kenny's a little busy, so it's okay. But the modulus is a really nice way to figure out this problem. So time is 6:55. Let's go ahead and take 15 minutes to give this a try. And we'll come back at 7:10. All right, let's go ahead and come back. I'm gonna go ahead and start the recording. Well, I've been recording this whole time. Oops. Oh, I need to stop it. All right. Let's go ahead and start going. So we had a array program that takes input from the user of how many cents they have, and then we had to break it down into its respective amount in coins, right? So the first thing was we wanted to receive input from our user that we can use, right? So we're gonna say change is equal to input, and then the agreement said that we have to ask the user, please enter an amount in cents less than $1, right? But one thing to note is that when we do this, in what format is our input going to be?
A
It's gonna be
string.
in a string.
Correct. It's going to be in a string. So what we probably want to do is once we receive our input, we want to wrap everything that comes back from here into an integer, right? So we can do some math with its response. Now let's go ahead and make sure we're doing this correctly. We can say print type change. I can say 87. I see I get class int. Let me add a colon and a space here so it looks nice and pretty. All right. So we're going to want to figure out what quarters is first because we want to start from the top, right? The biggest number to figure out how many quarters we have. And if we have less in our change, we can use a smaller amount of quarters or currency, right? So for quarters, we're going to take the change and we can either divide it or we can do floor, right? But let's go ahead and do change divided by 25. And let's print quarters and see what that gives us. When we do 87, I know that there's 3 quarters that can fit into this amount, right? It gives us 3.48, but the 48 doesn't really do anything for me, right? So instead of doing divided by 25, let's do divided and floor it by 25. And by doing this, I'm able to get the amount of quarters that are going to fit into my change. Now, once I've figured out what my quarters is, I need to make sure that my change reflects the fact that we already accounted for 75 cents of the 87 cents that was given to me by my user. So I'm going to say change is equal to, and then what I'm going to do is I'm going to do modulus, right? I can say change modulus 25. And let's see what this gives me. 87, and I get 12, right? Which is correct, right? Because by fitting 3 quarters into 87, it gives me 75 with a remainder of 12 left. So I can do it like this, or I can simplify this and say modulus equals 25. Right? It's very similar to plus equals. We could do minus equals. We could do times equals, right? But we could do modulus equal as well. So we could do it in one line. It's going to take the change. It's going to use the modulus with 25, right? And it's going to assign that value into change, right? Which is going to give me the 12. And now I can say dimes is equal to change divided by 10. And we're going to divide that 12 by 10. And it's going to fit in once. And we can see that if you like, but I'm sure you guys probably got it this far ahead. 87. We see here dime is the first thing we print out. We saw that one dime was able to fit into the 12 that is now change, right? After we account for dimes, once again, we're going to update what our change is by using modulus equals by 10, which will bring us down to 2 pennies. We can then say nickels is equal to change divided by 2. And let's see what this gives us. It's going to give us 1. Why did I say 2? My apologies. Divided by 5. There we go. Gives us 0. Okay, I'll use the wrong division. When we try to divide the change, which is right now 12, by I'm sorry, not 12, it's 2, right? Because we already took into account the dimes, which brought the change to equal to 2. And we try to divide it by 5, it doesn't fit in there. All right, it doesn't do anything for me. All right, so it leads it to 0, which is fine. I can then say change modulus equals 5, and let's print out change to see what it still is. 87, and change is still 2, right? Because we weren't able to divide it by 5 equally. And finally, we just say pennies is equal to change, right? Because at this point, I know that whatever is left over change, I can't fit a nickel into it, a dime, or a quarter. So pennies can just equal change. And finally, I can say print your change will be colon space. And then I say print Q3. And we can format this in a bit. I can show you how. Zero P2. Oh, my apologies. This has to be different. I'm hard coding this. This is wrong. This should be an F string. And then we want to say Q and pass in quarters. And same concept for here. This should be an F string. It's going to take in D. This should be dimes. This should be N for nickels and pass in the variable nickels. And pass in P for pennies and the variable for pennies. Now let's run this. I'm going to say 87. And I now get your change will be 3 quarters, 1 dime, 0 nickels, and 2 pennies. Do I have any questions on how I achieved this outcome? Were you guys on the right track? Okay. Katie says, what does modulus equal do? Well, let's say I have a variable here called num is equal to 5. If I say num plus equals 2, and then print out num, what does num give me? Well, Kenny, it's going to add the 2 into the num. If we do minus equals 2, it'll subtract this number of 2 from the variable num and it's going to save the result into num. Right? We can do the exact same thing with the modulus. Right? If I say num is equal to 10 modulus 3, this will give me a remainder of 1, right? Because 3 fits into 10 3 times, which will give you 9, but it has 1 left over. Well, a quicker way of doing this is by having something like num1 is equal to 10, and then we can say num1 modulus equal 3, and this will give me the exact same thing, right, of 1. So it pretty much does the like the plus equals, minus equal, or whatever operation you're doing, in a much more simpler format without the extra steps. Right? Instead of saying num1 modulus 3, which will give me the same thing, we can do it all in one line with less code. Now it's not a lot, but it's quick. Any questions? Right on. That's going to conclude our pennies or our coins.py. All right, comparison operands. Right, comparison operands. What happens? What happens if the person gives me a number that's not in cents less than $1? Should this still work? Because that's not what I'm asking the user for. But if this little goober gives me 187 instead of 87, is that what I want? No, right? This should only work if the input matches what I'm asking from my user. And in that event, we can use comparison operators, which are fairly similar to JavaScript, right? We would say if change is greater than 100, we can say something else. Actually, maybe let's not use this example yet because we haven't gotten to the if else statements yet. So let's put a bookmark on this. Let's just talk about operators in general. Let's say num1 is equal to 5, num2 is equal to 10. If I print out num1 greater than num2, what this is going to return to me is going to be false, right? Because this is going to compare one variable to the other, and it's checking if num1 is greater than num2, which will return a Boolean, right? Because 5 is not greater than 10, it gives us false. So we're able to check if something is greater than. We can see if something is less than, and it gives us true. So just like JavaScript, we can check greater and less than, but we can also do less than or equal or greater than and equal. Let's say num2 is 5. Is 5 less than or equal to 5? Well, it is equal to it. So I get true. If I put 4, I'm going to get false because it's no longer less than and it's also not equal to it. So we can use less than and we can also use greater than, which works the opposite way of the less than way, of course. We can also do comparison to see if something is equal to or not equal to. Is num1 equal to num2, which is true? If I put not equal, it's going to return false because they are equal, right? Print num1 not equal to num2. Well, they are equal, so this is going to return false for me. Right? This is comparing if these two variables are not equal to each other. But because they are, it's going to return false. Right? Now, one thing that you might be used to in JavaScript is that JavaScript allows you to use 3 equal signs. Who can tell me the difference between 2 equal signs and 3 equal signs in JavaScript?
With 3 equal signs, they have to be the same like value or whatever and type. And then 2, it can be, you can compare like the integer 5, 2 equals, and the string 5, and that'll still return true.
Correct. Right. It's how strict you want to be on the comparison, right? Where if you use 2 equal signs for the string of 5 and the integer of 5, that'll return true. But if you try to use 3, it's going to compare the type, which although 5 is equal to the integer 5, but because there are two different data types, you will get false. Python does not support that. Right? Python does not support that, so be aware of that. Do I have any questions on that? All right. We can also chain operators, right? Chaining operators or just chaining in general, right? To chain stuff in JavaScript, you're probably familiar with something like this. If no, let's leave if we can say something like num1 and num2. Let's go ahead and comment back these in. We can say num1 is less than num2. And if I want to add something different, I can say and, right? You guys are used to doing something like the double ampersand to use the and. In Python, we don't use the double ampersand. We use just the word and in lowercase. Right? In lowercase, the word and. So once again, more familiar with English than JavaScript, right? It's more user-friendly. You can specifically write the word and that's how it will compare something else. And num1 is equal to num2, right? And this is how you can compare two different things happening, right? You might be tempted to do this, where you put it in parentheses. Although it will work, it is not needed, right? Although it will work, it is not needed. It can still compare the num1 and num2 with and without this. Now, this is going to fail because obviously num1 is not less than 2. We can say if num1 is equal to num2 and num1 is equal, let's say type of num1 is equal to int. It is an F statement. Print hello. This should work. Yeah. All right, so we're able to compare. Notice that we didn't use parentheses on either side, but both of these pass, so therefore we went into this next code block, and we'll talk about if statements, which you can already see are already fairly simple, but we can chain them. Now, we talked about and. What about or, Roger? Well, in JavaScript, we use the double pipes. Here, guess what you use? Correct. Just the word or. Right? So instead of using these symbols, you want to use the word to represent the and or the or. Right? So we can say num1 equal to num2, or the type of num1 is equal to int. And you can do this right here. We can compare the type of something to a specific type to see if it matches to do one thing or another. But changing operands, we're able to use the and, but we can also say it's something like num1 less than 6 and 6 greater than 3 or greater than num2. So you're able to chain them in this manner as well. Right, we're able to check if num1 is less than 6 and if 6 is greater than num2. So two different ways of chaining the operators, or three actually, because you can use the and, the or you can just straight up just use this syntax here, or you can do multiple checks back to back. Any questions? If you feel like we're going a little too fast, the slides are available to you, so you can always go back to the slides. Everything I'm covering here is in the pacing of the PowerPoint. Just like we can compare integers, we can also compare booleans. right? We can say bool. Let's go with bool 1 equal to true. Bool 2 is equal to false. You can say bool 1 and bool 2, and then do something. We can say true or false, and that'll work. True or bool 2. We can do that. One of the examples you see here is comparing things. We can say if 17 is greater or equal to 10 and 5 modulus 2 is equal to 0, then we want to do something, right? So you can, it's the same as JavaScript, right? The same syntax. The biggest thing here is you don't use parentheses, or you don't have to at least. It's not the standard in Python to use parentheses unless it's like a long equation that you might want to kind of wrap around so you can understand it. But it's not like the standard operating procedure for it, right? And you are able to change these together. You can also use the not statement. We say not true, then we can do something else, right? If not bool 1 or not false, we can also say not 17 greater than or equal to 10, then do something else, right? So we can use a not to check if something is the like not whatever you're checking against to do something. So a lot of ways to compare, right? A lot of ways to use the greater than or equal to, the and, the or, the not. Which one you use for your situation is all going to be dependent on you and the situation itself. You have different options, but that's how you compare Booleans and logical operators. Do I have any questions? Right? So as you can see already, if you know that one language already, it's pretty easy to pick up the second one, right? A lot of it's fairly similar. It's just some small syntax differences. Now, let's talk about data flow and if statements. You kind of already saw me start doing it, but to start an if statement, all you really need is just the if, right? If num, let's say num equals 10, if num minus 2 is equal to 8, to start an if statement, you don't need parentheses on the end to do it. All you need is just start your check with the if statement and then just go right ahead and start typing what you want. It'll still work if you want to use parentheses, but that's not the standard of writing Python. Now, I say this because some of you guys might be a little stubborn, and because you're so used to JavaScript, you want to just still use them anyways, right? But you have to remember, right, that it's not going to be just you that's going to be using this code. Other people are going to be using it. They're going to be looking at it. One day you might leave the job that you're working at, and someone else is going to have to pick up your work from where you left off. They have to debug it or improve on it, right? We always want to make sure that we're using the best practices. But the if statement, we're going to start the if with the if word, and then we add our logic. Now, to start the data flow of a code block to do something, in JavaScript, you're very used to saying if num minus 2 is equal to 8, and then you would do a space and start curly braces. You don't do that in Python. You do not need curly braces. You start it with a colon and just a colon. That colon specifies to your code that you're starting a new code block. But Roger, how does my code know where it starts and ends if it doesn't have curly braces? Well, that's represented by the indentation of your code, right? The moment I add that that colon here and I press enter, you see that automatically it's already being indented because my Python knows that this is a new code block. There is exactly 4 spaces between, and we can see here the 4 dots between my indentation. So a standard indentation is either the button of one tab, so you tab it once with a tab button, or you use 4 spaces with your spacebar, right? So that starts one indentation, and that represents the first code block, right? That's how it knows where the code starts and where it ends. If num minus 2 is equal to 8, then I want to print this solution is the number 8. Right? This solution is the number 8. Now, what if I want to use an else statement? Well, just like the if one, very simple. You just go to the next line and you type in else. And here, you're going to do a colon and then go to the next line. Right? Because if it does not equal this, then we have to do something else. But if it does, run this line. To tell it to do something else, once again, you have to start a new code block, and then you do here. Print. This solution is not 8. And this is your first if-else statement. Right? If I run it, it's going to print out that it is 8. But if I say num minus 1, it's going to run the else block. Right? Because when it came here, it fails this check here. So it jumps to the else statement. Every time a new code block starts, it's indented. Right? Every time a new code block starts, it is indented. What if I want to use multiple if statements? Right? What if I have multiple things to check? Right? We use an elif. We use the elif statement, right? Elif num minus 1 is equal to 9. Print this solution is 9. Right. Very similar to JavaScript, but here I think in JavaScript it was like else if, right? We don't use the full else, it's elif. Elif. So small syntax differences, but still fairly similar to JavaScript. We're going to check if it's equal to 8. If so, print out this number is 8. If it's equal to 9, print the solution is 9. Else, print the solution is not 8 or 9, right? So this is how we do if statements, elif statements, else statements, and how the flow of data flows throughout your code block. If I wanted to add more functionality within this if statement, if num minus 1 is equal to type, or if we could say int, if type of num minus 1 is equal to int, print this is an integer. What nested if statements, you just follow the same code flow, right? When I start this on line 28, it's going to subtract 2 from 10. And it's going to check if it's equal to 8, which will pass. And it's going to print out line 29. But because this check here passed, it's going to run everything within this code block. When it gets to line 30, it's going to run this. It's going to check if it's equal to an integer. And if it is, it's going to print out this as an integer. And we can also add an else statement within here. Right? So we can nest them just like we do in JavaScript, right? And you can already see the code block for this section right here. It's being shown here by this line. It's another indentation, right? So no curly braces needed. It's all used. It's all done by the indentation of the code. Do I have any questions on anything that I just covered? All right. Right on. Let's go ahead and take another 10-minute break. And we're going to come back at 7:50. I'll see you guys in a bit. Recording. All right. So we're going to go ahead and continue. We were talking about for statements. I'm sorry, if statements, if else statements, elif statements, and so on and so forth. Now, the next thing we're going to get into is going to be loops. If you're following the slides, it's talked about while loops, and then it talks about for loops afterwards. We're going to start with for loops instead. And once again, I know I keep saying it, but just like JavaScript, it's going to start fairly similar. But there are some actually very specific differences with for loops in Python in comparison to JavaScript, right? The JavaScript example, to make sure we're on the right page, looks something very similar to this, where we would start a for loop with the word for, and then we would say, let I equal 0, and this is just an example, while I is less than 10. Pretty sure. Here we go. I plus plus, and then we would open up curly braces and we could say something like print I, and this will run this for loop, and it would start the I at 0, right? And then we set a condition that we're going to run this for loop until it's, greater or equal to 10, right? So this is going to run until it's equal to 10. And every time that this runs, we want to increment with the plus plus. Well, this looks very different in Python. We will start it using the for loop, but we don't need all this extra mumbo jumbo here. All we say is for I in range. If you wanted to get a specific range, well, you're going to use the range method to let it know what range we want to go through. For I in range of 10, I want to print I. And let's say I is equal to 0. And we can run this. And as you see here, it's going to start once again from 0, right? By default, it starts at 0. And it went up to 9. Now, the way that the range method works, it takes a couple parameters. But range takes 3 parameters to be exact. The first parameter is the start. The second parameter is the stop. And the third parameter is the step. But by default, if you do not give it any other parameter except one parameter here, this is going to take the place of the stop, right? If you only pass in one item inside of range, it's going to take the place of the stop, right? By default, the start is set to 0, right? And we see here, actually, I don't even need this, I believe. I don't even need to say I anything here. There we go. Yeah, we didn't need to create a variable because it's starting at 0 anyways. We say for I in range of 10, I starts at 0, right? Because that's the default of the range method. And it's going to stop at 10. Notice that it didn't print out 10. It's up to, but not including the stop number. And that's very important to know. Now, if I want to specify that I didn't want to start at 0, I would say, let's say 1, 10. And my range method would know that, hey, I'm going to start this count at 1, and I'm going to count up to 10. And now, instead of 0 to 9, we get 1 to 9, right? Well, I want to print out everything from 1 up to 10. So once again, the stop is up to, but not including. So if I wanted the 10, I would have to make the stop 11. And now we can get that 10. Right? So the range method here in this for loop is going to give you a range of how many times you want to iterate through something. Now, the step. The step is referring to how many numbers is going to increment after every iteration, right? Here, this is pretty much pretty similar to what this is, right? The I plus plus, how does this work? What is it going to increment?
By 1 every time.
By 1. If you want to increment by 2, you would do I plus 2, right? Or I plus 5, right? The way that we do that here is we use the step method. Instead of increasing by 1, I want to increase by 2. And now you see here I get 1, 3, 5, 7, and 9, right? Because they increase by 2 every time they went through the iteration. So this is the exact same thing as this, right? You tell it where to start, where to stop, and how much you want to increase. Do I have any questions?
So if
All
you
right.
leave the step empty or just like not in there, does it just do it by 1 automatically?
Correct. The default is 1, right? Default 1, and the start is default 0. Sound good? All right. And here's my favorite part about for loops in Python. Although we're able to replicate the exact same thing we did in JavaScript using the range method, as you may have noticed, if you want to grab a specific item in a list, you would have to start this and then use the I as an index to grab an item, right? In Python, you don't have to do that. You can iterate through a list without doing that. We can say list of words. The first one to be hello. Second one is my. Third one is name. Fourth is. And then we're going to say Roger. All right, this is a list of different strings. Normally, you would do something like this where you would start a for loop that you can increment from a specific number. So you can grab index. And then you would say something like print list of words. And then you'll pass in the index. Now, this might give me an issue. Why do you think it's going to give me an issue?
Would you need to use instead of range, would it be for I and list of words?
Yes, but if I wanted to use the index, would that work? If I want to use this logic, how would that work? I don't want to get specifically the up to 11 because there's only so many items in here, right?
Would you use a dot length method like in JavaScript?
Yeah, I will use the dot length method, right? In JavaScript, it would be list of words dot length. Here, you don't have to do it this way. What you do is you wrap around the variable you're trying to call the list, and you say length. Len, list of words, right? Len, list of words, and this will get you the length of this list, which is 1, 2, 3, 4, 5. So this is for I in range of 5, right? Because that's the length of this list. And we're going to print out the list of words at each index, starting from 0 up to 5. And we're able to grab every single item by its index, right? Very similar to how this does it, where you would say something like print list of words with I, right? That's how you do it in JavaScript, right? You have to end up getting the length of what you're trying to use here to figure out how far you have to loop through, and then use that length and the index to grab the specific item. You don't do that in Python. You can, I just show you how, but it's a much simpler way, and it's as simple as just calling the list that you want to loop through. For I in list of words, print I. And that's going to give me the same output as I did before. Because instead of I taking the place of a number within a specific range, what this is going to do is going to grab this entire list. It's going to grab each one of these items in this list one by one, and that I is going to take the place of that. Right? So when I start this for loop, for I in list of words, I'm going to start at index 0 and grab the first item inside of this list. So I can print I, and it's going to print this item. Right? That's the beauty of for loops in Python in comparison to JavaScript, where you would have to specifically specify the length of the list you're trying to loop through, and then grab each item by the index individually. Here, you don't have to do that roundabout method. You loop through the list itself. Do you have any questions about for loops with lists or using the reach method?
I got one question. It was just you stated like for each index of the list, you said 1, 2, 3, 4, 5. So in Python, does the list start at 1 or does it start at 0?
0.
Okay.
I just meant to say like the first item, but yes, it is in the 0. The index is still the same. Good point. All right. So we talked about for I in list of words to loop through a list. The reason why we're able to do this is because it's a sequence, right? It's a sequence of strings in an order of the index. You can also do this for individual strings. Instead of list of words, let's say I had my name is equal to Roger. I can loop through strings because strings are fundamentally a sequence of characters, right? And they're used the same way. Each one of these characters are at a specific index within this string. The first R is at index 0, the O is at index 1, and so on and so forth. And I'm able to loop through strings as well and grab a specific character, right? Because strings are also sequences that are used by indexes. Do you have any questions about doing a for loop with strings?
I got another one. So what if you're trying to loop through like a concatenated string? Does that still work the same way?
Yeah.
Okay.
It's still a string at its core. Anybody else? Jason, how you doing?
Good. I guess one question as far as like the proper way, like for example, like I know I would typically be index, a JavaScript for loop, but wouldn't it be better to use like say like for like char in my name or list of words, it'd be like for word and list of words. Would that be more
Yes.
proper?
Of course, right? That goes down to like naming conventions and using, semantic names to specify what you're doing, right? If I was actually calling this out and this was actually something I wanted to use, I would say for word and list of words. You're absolutely correct. Print word. Maybe I should start like that from the beginning, right? But yes, you would want to give this a specific alias to whatever item you're looping through to let you know what you are printing out, because I could be a little confusing. Thank you for that. All right. Now, let's go ahead and do this. Let's say for num in range of 1 to 11, I want to print num, which is cool. I get 1 through 10. But what if I only want to grab all the numbers until I reach a specific number? Let's say 5. Well, the next thing that comes along is the ability to break or continue in code, right? If, as I'm looping through my for loop, I encounter a part in my code that I want, and I do not want to continue looping through this long list of items, I can use the break method. I can say if num is equal to 5, break. Let's go ahead and say print num. I'm going to print the number, but if it's equal to 5, I want to break afterwards. And when I run this, it's going to print everything from 1 through 5. But once it prints out that 5, I'm checking if it's equal to 5. And if so, I want to break out of this loop. And I no longer want to continue. Right? So we can use the break statement to stop in our code at a specific condition so we don't continue running this for loop in the event we've already encountered or got what we needed out of it. Right? So the break allows us to stop a for loop, but we also have another condition, which is called the continue condition. Right? Give me a second. I got to sneeze real quick. Sorry for that. All right. But just like we have the break, we have the continue condition as well. And the continue condition allows us to, instead of running a piece of code on a certain item, we could just continue with the rest of the for loop. And we can say, if num is equal to 5, I want to continue. Else, I want to print the num. Right? And when I run this, it's going to print 1 through 4. And when it gets to 5, it's going to just continue with the loop and it's going to skip the rest of this code block. And it won't print it out. Right? And it goes to 6, 7, 8, 9, 10. Right? So we can use the break statement to stop our code whenever we meet a specific condition, or we can use a continue in the event that we're still working within this for loop, but there's a number that we want to specifically avoid, or there's something that we don't want to mess with, but we're still not done finding what we're looking for, right? So we can use a break statement or the continue statement. I would say the continue is fairly similar to the pass statement, if you guys ever use that. Do you have any questions on the continue or the break statement? All right. Now, we learned about for loops. Let's talk about while loops. All right. What is a while loop?
Oh, it's like while a specific condition. Oh, you can go ahead, Jason.
Oh, yeah, it's pretty much like if a specific condition is true, keep running the loop. When it's false, stop, exit the loop, that kind of thing.
Yeah, right. It's a condition that's going to keep running, or it's a loop that's going to keep running until it meets a very specific condition, or until a condition is no longer met. Right. It's another powerful loop that we have to our ability. I don't feel like it's used as often, which for good purposes, it's fairly simple to exceed your runtime whenever you use a while loop. And it's very easy to get an infinite loop when using them. So a lot of people use them very sparingly. But for a while loop, you're going to start it by calling the term while, and then just give it the condition. While num is less than 10, I want to print out num. Right? Let's say num is equal to 0. Is this a good while loop? Does this syntax look right?
No, it'll be infinite.
Yeah, it's gonna be infinite, right? Because num is equal to 0 to start. And when I start this while loop, I'm saying, hey, I want you to run everything within the code block of my while loop if my num is not greater than 10. Which it's gonna work, but it's never gonna stop because at no point do I ever change this condition to exit out of this code block. So I want to say num plus equals 1. And then when I run this, I'm able to print out num until it's equal to 10. And then I exit out of this while loop. A way that we can do this as well is say something like total score is equal to 0, while total score is less than 100. I want to do total score plus equal int input, enter your score for this round. Print total so far is equal to, and then we'll add total score. And then this will keep running the code where it's asking for input until it's greater than 10. And I can say 3, 2, 5, and it breaks out, right? So we can keep running something to get a certain task or make our program do something until we reach a certain condition. You want to avoid infinite loops, right? Does everybody know how to get rid of an infinite loop if they ever encounter one?
You mean like Control C?
Yeah, Control C, right? It's pretty common, but essentially, if I run this code right now, as you see, it's going to keep printing out a 0. If I want this to stop, I can terminate this call by pressing Control C, and I'll get a keyboard interrupt. Right, so I was able to stop my code completely, so it no longer runs that code. Right.
What I'm reading here, I guess, is while loops is better for like if you don't know, if you don't have an idea of the number of iterations, while loop might be better to use than a for loop.
It has its purposes. For example, uh, think of our game that I mentioned to you guys that we're gonna write. We're gonna run our game in a while loop, right? And the while loop is gonna say while true, or let's say game running is equal to true. While true, then I want to do everything in my game. And when am I gonna set it to false? Is the moment that I no longer have any lives or I die. And then I'll set it to false, and it's gonna stop my game. Right? That's a good time when while loops are really useful. You'll see that whenever we're making the game, that a lot of the game development, uh, it's nothing but loops, right? That we keep running a sequence until it's done. Uh, a, a while loop has its purposes. For example, if you're trying to find a specific number in a huge list of integers, right? You might want to run a while loop until you find the integer, or until you run out of integers. For example, let's say you're trying to find the number 5 within the list of 1,000 different numbers, and every time you encounter a number and it's not equal to 5, you want to remove it out of the list, right? And you keep doing that until you no longer have numbers in this list, right? And then once all the numbers are no longer in this list, it's gonna run to false, and it'll tell you whether it found it or if it didn't, right? So it's very situational. Um, it is done whenever you don't have a specific outcome like in mind, or I guess a specific measurable outcome, if that makes sense. Where like, I'm looking specifically for this one item, so I'm gonna keep doing this until this. You can keep doing it to do multiple tasks until you reach a specific condition. Not necessarily measurable like you would in a for loop, where you would measure it by the length of a list, a length of a string, or until something does something else. So I guess maybe that's not the best way to explain it, but it is very situational. They're not used too often, as I said, because they tend to be a little bit difficult to control sometimes, and they can continue running and cause run issues. All right. Is everyone here familiar with nested loops? Okay. All right, so for nested loops in Python, let's say I have a list of animals. I have dog, cat, bird, turtle. I'm gonna start a while loop where I'm gonna say for animal in list of animals. And if I print this out, you'll see that we get every single animal in here. But I'm gonna start a nested for loop in here. And it's gonna have the same syntax as this, right? Using the for method. And I'm gonna say for char in animal, print char. Right? When I start this for loop, it gave me access to every individual item within this list every single time this runs an iteration. The first animal it starts with is going to be the dog. So then I can use a nested for loop to iterate through that dog that I'm currently looping through, to loop through it and grab every single character within this dog. Right? So nested for loops, same syntax as you would a regular for loop. Right? All loops can be nested, and the data flow logic can be embedded within them as well. Right? It's all just separated once again through this indentation. Any questions on nested for loops? All right. We're about halfway through, a little over halfway to the Python crash course. The next part is going to be the number guess.py. So in your directories, go ahead and open up the number guess.py. And it should be empty. Yep, I figured. But I want you to look at the README. The README will have the instructions. You're going to write a program that prompts the user for an integer that the player would try to guess. Now, you can go above and beyond and figure out how to get a random number, or you can just keep it very simple. So you ask the user for input. It'll give you like the number 50, right? If the player's guess is higher than the target integer, the program should display too high. If the user's guess is lower than the target integer, the program should display too low. The program should use a loop that repeats until the user correctly guesses the integer, right? And that's kind of right here your keyword for what type of loop you should use, right? It should run a loop that repeats until the user correctly guesses the integer. Then the program should print how many guesses it took. When you run your program, it should match the following format. You should get a prompt that looks very similar to this, where it says enter the integer for the player to guess. And you can give whatever you want. And then they're going to guess. All right, so you give it -12, and they add their guess, which is 100. And it says too high, try again. They add 50, too high, try again. -2000, too low, try again. And then they add -12, and it said you guessed it in 4 tries. If the user guesses the integer in 1 try, then your program should print you guessed it in 1 try. So this is a very specific outcome, right? Does anybody have any questions on this assignment? All right. Let's go ahead and give it about 10 minutes, but I would like for you guys to turn on your cameras the moment you guys are done. Let's give it a try. So before we broke up, we went into the number guess.py. Let me go ahead and cd into it. Let me open this up and let's give it a try. So we have to write a program that prompts the user for an integer. So number is equal to int input, and then I'm gonna say enter the integer for the player to guess. Or no, let's go ahead and do something different. Let's say guess a number. Say guess.
Do you mind putting it on your screen?
Oh, my apologies. Thank you very much. There we go. We're gonna start here where we're gonna ask the user for some input. I'm gonna ask it for guessing a number. But I'm gonna go ahead and I'm gonna predefine the number here. I'm gonna say correct number is equal to 12. I'm gonna ask the user for input. But we want to keep asking him until he gets it correct, right? So maybe doing this in this fashion is not correctly doing it. We might want to start a loop so we can constantly ask him until the answer is correct. And we'll say guesses or guess is equal to 0 or something like that. Or we say correct is equal to false. And we'll say while correct is equal to false, then I want to ask the user for input. Right? So I can use this right here to keep track if the user has found the number that I'm trying to get him to solve. And I'm gonna say if number is equal to 12, correct is equal to true. And if number is greater than 12, I want to say print too high, try again. All right, so in the event he gets to the correct number, I'm gonna set this to true, and then I'll handle what logic is gonna happen after he finally solves it. But in the event it's higher than the correct number, I want to say print too high, try again. Else, I want to say print too low, try again. And why do I say else instead of elif? Well, because if it's not equal to and it's not greater than, then the only other option is that it's less than the correct number, right? And one thing that I also need to keep track of is how many guesses my user has made, and finally tell him the guesses. So maybe add a number here that says correct or not correct guess. Let's say guesses is equal to 0. And every time he makes a guess, I'm going to increase the count by 1. Right? I increase the count by 1. And then finally, once he actually finds it, I'm going to say oh, it's already true here. I have it here where correct is equal to true, which will stop the while loop and say print. I'm gonna make an F string here. You guessed it in. I'm gonna add the guesses. Tries. And let's see what it looks like so far. And we can make some changes in a bit. Let's say Python number guess.py. And as you see here, it starts a while loop and it prompts me for inputs. I'm gonna say 10, which was too low, right? Try again. I'm gonna say 15. It says too high, try again. And then if I say 12, it says you guessed it in 3 tries. But we have a condition here that we have to set is that if the user guesses the integer in 1 try, then your program should print you guessed it in 1 try. And as of right now, if I do it in the first try, it doesn't give me that. It says you guessed it in 1 try, which is not accurate, right? So we should say if guesses is equal to 1, we want to print you guessed it in 1 try. else print, you guessed it, in so many tries, right? And now if I say 1, it gives me too low, try again. Do I have any questions on this assignment?
I'm a bit confused on the like how you worded the while loop, like while correct equals false. Because I actually didn't put that because I was like struggling with that for some reason. But when I put yours, it was doing an infinite loop on my console or my terminal.
Yeah. So I create a variable that's equal to false, right? And it won't change until he finds the correct number. And you might have an infinite loop because you don't have a condition that's going to break this while loop out of it, right? So you have
Yeah,
to
you're right.
that once he encounters that right number, you make it true.
Okay.
Right?
Yeah, that makes sense. That's exactly it.
All right. Anybody else have any questions? All right. Now we can add some other functionality in here. Like, what if I don't want to preset this to 12? Well, there is a module that Python gives us, and it's called random. So if you go to the W3 schools for Python random module, there is a rand int that we can use that it returns a random number between the given range using the rand int method. We can click it and it can give us an exact example of how it should be worked. We import random, and then we use random.randint and give it the range of what we're looking for. And notice that it tells you both the number 3 and 9 are included. Right? It's not up to including, it's or up to or before. It's both are included. So we can use that to our advantage. And I can either import all of random, or I can say from random import randint. And then I'm going to say randint. And I want to go from 1 to 20. And I can leverage this. So I can have a random number every single time. It says too low, try again. So I'm going to try 15. It's too high. Let's go with 10. Too low. I'm going to go with 12. You guessed it, in 4 tries. And my bad. This is hard-coded. I need to change this. If number is equal to correct number. There we go. Let's go with 5. Too low. Let's go with 15. And it was 15. You guessed it in 2 tries. Right? So I was able to use a random generated number to make this a little bit more dynamic, where I don't have to hard code a specific number. And I can actually make this where I don't know the answer and I can try it out myself. Right? This time it was 11. Now, what if they add something else besides an integer? Right? What if they do the word 5? I'm going to get an issue here. So you can add some more functionality to make sure this doesn't happen. We can give them to guess a number. And we can say if type number is equal to int, then I want to run everything below it. Else, we should say this is not a valid number. Right? So once again, if I do 15, oh, it's not This is not a bad number. Okay. If int, here we go. We have to add some other statements here. What's happening is that because I no longer convert it into integer, it's trying to check the correct number against the number, which is a string, and it's going to fail. So all these, when I'm comparing them, they have to have integer. Now let's try it again. This is not a valid number. What is going on? Let's add that instead. Let's convert it.
Could you maybe just put int in the number line and then like let's just say somebody puts in a string by accident, a string could be converted to an integer and then maybe that would work.
It's going to give me an error. Are you talking about keeping int here?
Yeah. Yeah.
It's going to still give me an error.
Okay.
Right? Because when I run this and I say 5, let's go with type. There we go. So it's working now, but the moment I add 15, I get the error there.
Oh, okay.
Right? Because it's going to attempt to convert it. Right? So the moment I add this int here, it's going to try to convert it into the number and immediately give me that error. So it's not what exactly I want.
I mean, I guess you could do a try except, maybe.
Correct. Try number is equal to int number, except print this is not a valid number. Right? And then we can probably get rid of all this other stuff. Let's see if the try and accept block works. There we go. Accept value error. Oh, I'm getting an issue here. I want to move this here. Okay. There we go. Okay. Let's figure out what's happening here. All right. So it's going to ask me for some input, right? To get the number between 1 and 2. I do not convert it into integers yet. I'm going to take this feedback from the user. And then we do here what's called a try and accept block, right? What that means is it's going to try to do everything within this block of code here. And if at any moment one of these items does not work, it's going to break out of this try block and so they go into the accept block. It's almost like an if-else statement, right? So it's going to try to convert the number into an integer. And if it works, it's going to guess it like normally. But the moment that they add a string and I try to convert it into integer, it's going to fail. And it's going to raise an error, which you saw was the value error, right? And what I did here is I'm checking if there was a value error. And if there is, I want to print this is not a valid number, and that's going to allow me to continue with my code. And if you see here, when I do 15, it does not stop my code because I figured out a way to handle this error so it doesn't break it, right? But if I remove this value error here and I just leave an except block, it's still going to catch it, but oh, okay, I guess it didn't do anything else. All right, disregard everything I just said. Regardless, it's still working. The trying to accept block. It's capturing whether it's an integer or a string. Did I just confuse you guys even further, or does all this make sense?
Makes sense. It's just like I think more practice with JavaScript is needed to really understand it for me.
With Python?
Or yeah, Python.
Okay. Yeah. Essentially, I had to add it in a try and accept block because at some point I need to be able to convert this into an integer. But every time I try to do that, the moment I did that, it gave me an error, which would immediately stop my code. But this try block, it handles that error, so it doesn't stop my code, but instead it prints something out for me, right? So it's the same as saying if number is of integer type, do this. If not, do the other, right? I just added within try and accept block because a try and accept block is a lot more powerful for handling stuff like that where you're going to get an error, right? But we'll see this again. It's not going to be the first or last time you'll see try and accept block. I would use it more often, and it will make a little bit more sense later on. All right, we're going to we're going to stop here because the next part of the lesson is heavy on functions, and I don't want to start something that can't finish. Besides, we don't have too much time anyways. So I'm going to go ahead and stop the recording.